Factoring polynomials involves breaking up a polynomial into simpler terms, this being the factor, such that when the terms are multiplied together, they equal the original polynomial, taking a complex form and going to a simpler form. So what does distribution have to do with anything? Well, if you take the 3 and multiply it by the x, you get 3x, and you take the 3 and multiply it by the 3, and you get 9. So it would look like this. This is important because factoring is the same process but backwards. If you take a 3 out of 3x, it goes on the outside of the parentheses, and then you take 3 out of 3x itself, and you get x. Then 3 out of 9, and you get 3. That's how you factor. So let's look at some examples. In number 1, we see that it is a trinomial because it has 3 terms. You also see that it has a 4 divisible in each term. Along with the 4, you see that x to the 4th is able to be divided as well. So your greatest common factor is 4x to the 4th, taking the 4 out of the first term and the x to the 4th out of the third. In your parentheses, you would see after dividing the first term, it is x squared. Looking at the second term, you see after dividing that it is a positive 5x. Looking at the third term, you see that it is a positive 2. Because this is the simplest form, that's as far as you can go. Looking at number 2, you can see that it is a trinomial as well, because it has 3 terms. You also see that it has the negative 2 in common with everything else. So your greatest common factor in this case would be negative 2. Taking it out of the terms would leave you with a x squared in the beginning of the parentheses, a negative 4x in the second part of the parentheses, and a positive 6 as the final term. You know that a negative minus a negative is a positive. Looking at number 3, you see that a binomial is shared by both portions of the equation. You can pull z minus 8 down. You're left with 6z and a positive 4. This you can pull down as well. You think you're done, right? Wrong. You can pull out a 2. It's your greatest common factor. So you're left with 3z plus 2. Move the z minus 8 down, and you're in factored of simplest form. Looking at number 4, it seems difficult, but it's not. If you do the concept of grouping, it's simple. You divide the equation into 2 parts. Looking at them individually, you find the greatest common factor, this being 2x to the third. You then divide it out of that portion of the equation, so you would get 2x minus 1. Looking at the next section, you would pull out a 3, but pull out the negative, it'll make your life easier. You would then get 2x minus 1. Because you now have 2 binomials that are the same, you can pull them down as 2x minus 1. You're left with a 2x cubed and negative 3, so you pull that down as well. You're now in the simplest form, so you're done. Looking at the next problem, number 5, you see that it's a trinomial. So you can use the method of a t-chart, which is a times c for the left side and b for the right. A would be x squared and c would be negative 24. That's the portion in the front, so 1 times negative 24 is negative 24. And b is 2. These are using the coefficients. You want to find factors that multiply to get negative 24 but add up to get 2. 6 and negative 4. You substitute them for the middle, so you would do x squared plus 6x minus 4x minus 24. Now, like grouping, you would take out the greatest common factor for the divided section. This being x, you would get x plus 6, and on the other side, this being negative 4, you would also get x plus 6. Pull down the 2 common binomials, x plus 6, and also x minus 4. Simplest form, you're done. Now you try it! Pause the video when you are trying to solve the equation and press play to see the answer following. Before I stab myself. Wake me up before you go. Is this even?